Alright, welcome everybody. This is DLL Cool J with Arch Cloud Labs, and today we're going to talk a little bit about GTFObins and how you can quote-unquote live off the land with a handful of Unix binaries. And if you're familiar with Windows LOLBAS, right, this project down here, we can pop that up really quick. GTFObins are just the Linux equivalent. There's been a lot of LOL talk out there with living off the land drivers, and I think there was just an OS X one the other day. I forget the name of it. It's Living Off the Orchard or something like that. Forgive me if you happen to be watching this and are the author. It's really cool. I just don't remember the name of it. So with all that, there's all these neat things and ways to execute code, so on and so forth. But that leaves us wondering, as you know, professional red teamers, penetration testers, so on and so forth, how do we integrate these into our workflow in a way that makes sense, right? LOL drivers was the other one I was looking for. Cool. But how do you integrate these into your workflow that makes sense without causing a bunch of things to break or writing all these like weird one-off tools, so on and so forth? Well, luckily, Metasploit actually just came out with a pretty cool thing of fetch payloads. Sorry, I'm pulling up the blog now so I can actually reference this as I talk. Cool. So fetch payloads, a shorter path from command injection to Metasploit session. Fun title. So effectively, if you're used to having, say, like a Python simple HTTP server, an Nginx server set up, so on and so forth, where you would then stage your Metasploit binary and then maybe use a PowerShell one-liner, Python one-liner, what have you, to bring down and execute your script. All of that's been kind of integrated into what they're referring to as fetch payloads. And this is an awesome write-up, definitely a quick read, worth giving a look to see how you could even get started using some of these tools in your workflow, right? And if we take a look here, right, we have a reverse TCP interpreter payload for Windows. We go ahead and do generate-f raw, and we get a nice, lovely curl command that's going to write it to the temp directory on Windows from our staging server with a bizarre URI name, right? And we leverage the start command to kick this bad boy off. Cool. So that's neat, definitely worth a read. But I wanted to show how you can integrate some other LOL bins to improve your workflow. And particularly, we're not going to do anything super exciting for this quick video. We're just going to leverage a good old Python one-liner. Something I'm sure we've all done at one point or another. You leverage the good old Python on the Linux machine to bring down a file you've stashed elsewhere. If you're a hack the box frequenter, this is not uncommon to you. Cool. So if we take a look at this file download in our GTFO bin here, we can see that this does more checking than what we really need to do. It checks for either Python 2 or Python 3. That's fantastic. We import URL lib requests as R, and then we go ahead and leverage the URL retrieve method to grab something from a binary, grab something from a URL and store it to a local file. In this case, it's going to be a local binary for us. Neato burrito. Now let's go ahead and take a look at what this code modification actually looks like on the Metasploit side, play with it a little bit, and go from there. So we're going to go ahead and take a look at the Ruby itself, so that way you can walk away with either recreating this or extending it into your own thing for Windows, so on and so forth. We currently have open under the Metasploit framework repo, the lib msf core payload adapter fetch linux options.rb, right? So these are the Linux options for our fetch payloads. And if we take a look here, in the default upstream, what we're actually going to see is that there's just curl, FTP, TFTP, TNFTP, and wget. But we went ahead and added this additional option of Python 3 because we're going to go ahead and make a Python 3 one-liner. So if you're looking to extend your Linux options or Windows options, so on and so forth, this is going to be a file that you have to modify for the actual MSF console itself. And if I pop on over to my MSF console, you know, I'm already preloaded and ready to go with a Linux reverse TCP shell for x64. But if I go ahead and type in info, we can see the default fetch command here is curl, but we're going to go ahead and override that and leverage Python 3. And I've already kind of populated some of these other parameters here of, hey, evil.bin is going to be the file name that we fetch. This is the IP that I'm currently storing it at. the port to listen on, so on and so forth. And where we're going to write it on the remote Linux host. Cool. So after you modify the Linux options.rb and you said, hey, I'm going to add another option here at Python 3, we actually have to go forth and then modify an additional file to say, like, what is Python 3 going to do, right? What does it mean to do something with Python 3? And that file is going to be fetch.rb. So fetch.rb is going to handle the vast majority of our actual staging, or let me just rephrase that. It's going to handle the vast majority of the creation of that one-liner to go forth and grab that staged payload and do all the fancy execution, right? So we have a handful of options here. You can read through this. I just kind of want to jump to the actual code that you need to modify because it's quite small. So I'll leave the rest of this for your own browsing pleasure outside of the video. If we go ahead and jump down here, we have these generate fetch commands, and this is what we want to augment because we want to write our own. And in the case of our GTFObins, we're going to leverage Python 3. So simply in this case statement, we're going to go ahead and add a Python 3 statement for the switch statement. And we see here we're referencing that fetch command. These fetch commands correspond to the other file that we were just taking a look at. So if we go ahead and scroll on down a little bit more, we will start seeing, let's say, the curl stager. How does this get generated for the curl command, the FTP command, so on and so forth. Effectively, all you need to do is take a big old block of code like this, copy and paste, and then populate the command variable with whatever your GTFObin or LOLBIN, so on and so forth, needs to do the execution. That's pretty neat because it allows for that rapid iteration of, here's a new LOLBIN someone posted on Twitter, how can I integrate it into my workflow? As a detection engineer, how do I go ahead and execute this to then see what this looks like from a detonation range, get the artifacts, so on and so forth. Nothing super crazy having to be done there. Effectively, all we're doing is substituting out the download URI for whatever the user puts in, and then the remote destination for also a user-generated parameter. And if I go ahead and actually show you the git diff here, right, it's pretty small, right? All I've done is said, hey, when Python 3, go ahead and return whatever the Python 3 command function generates. And if we go ahead and jump on down to that Python 3 command function, it's what we just saw. So, not even 20 lines of code altogether to get this up and running. That's pretty awesome. It is very easy to iterate on this, and that's what I'm hoping you walk away with. Popping on over to our tmux session here, I'm going to go ahead and say set fetch command to be Python 3. Do another show options to make sure I've got everything set the way that I want it to be. Python 3, I'm not going to delete it after I run, but you can do this if you so choose. We can actually check out the delete command. I think it's called like remove. Is it called deletes? Delete resource. Yep. So we can see that it just does an RMRF on Nix, and then on Windows leverages just the del command. Should you choose to augment that as well, go nuts. Cool. So we have this all ready to go. This looks good. Now let's go ahead and actually generate it. And the way you do that is by saying generate-f raw, and then this will give you a Python one-liner. So if you remember the blog post at the start of this video, this was referencing that there's a crazy insurgence of command injection vulnerabilities. And if you've been paying attention to CVEs this year, it's a lot with Soho routers and IoT devices, the usual suspects. But this allows you to quickly iterate and demonstrate those risks to your customers or your own independent research, so on and so forth. Definitely a neat thing that was integrated into the Metasploit framework, and I thought it'd be cool to make a video on it. So cool. We've generated our one-liner. That's great. Let's go ahead and make sure that we create our reverse handler as well after we execute this. So go ahead and we'll copy that. And I just have a Vagrant machine running Ubuntu 2004. We'll go ahead and copy that in. Boom. We see the callback. Give it a second, and then we'll have a session get opened. Lovely. If I go ahead and type sessions, we see that. Go ahead and interact with it. Boom, we've got our shell. Cool. So in literally less than 10 minutes, about 9 minutes and 53 seconds, I gave a quick demonstration on how to leverage those GTFObins, create a quick modification to the Metasploit framework itself and leverage the fetch commands. The last thing I'll leave you with is at the time of this recording, it was in the main branch, but I don't think it was in a release yet. So if you're looking in the latest Kali or something and you don't see this, you might actually have to git clone the Metasploit framework repo from the Rapid7 GitHub account. But you know, if you're watching this in 6 months from now, then that won't matter. But I hope you enjoyed this. If you found it useful, like, subscribe, share, all those things. If you found it bad, yell at me on Twitter. Thanks everybody for watching, and I'll see you next time.